Let's explore this official GMAT problem. To get the most out of this video, pause the recording now and solve the problem yourself. The correct answer is D. This is an overlapping sets problem, and the usual strategy would be to use the double set matrix. However, that's not going to work here because we have three sets. These houses may or may not have air conditioning, a sun porch, and a swimming pool. That's too much for a double set matrix to handle, so we need to look for another approach. It's very important to note that three set problems aren't very common on the GMAT and tend only to appear at higher levels. Really, this may not be an area worth investing your study time in. If you're short of time, then perhaps skip this topic. Also, I would recommend studying this only once you've scored 80 or above on your quant section in a practice test. If you're scoring lower than 80, then there are almost certainly more important strategies for you to master than this one. It's possible to approach three set problems with a Venn diagram, but that's almost always unnecessarily over-detailed and time-consuming. For this problem, and for most three set problems, we don't need to find out all the little overlaps between the three sets. We're concerned only with the number of houses that have 3, 2, 1, or no amenities. First, let's organize the information and deal with the percentages. 60% of the houses have air conditioning, so let's use the method of taking chunks of percentages. 10% of 150 is 15. Multiply that by 6 equals 90. There are 90 houses with air conditioning. Similarly, half the houses have a sun porch, that's 75 houses, and 30% have a swimming pool, that's 15 times 3, 45. These three numbers, 90, 75, and 45, add up to more than 150. There are more amenities than houses. How is that possible? Let's be clear that when we're told that 60% of the houses have air conditioning, this doesn't mean that 60% of the houses have only air conditioning. The GMAT is very consistent with its phrasing here. The meaning is, have air conditioning and perhaps other amenities too. That's why the number of amenities is greater than the number of houses. Some of the houses have more than one amenity. I'm going to expand this thought and develop it into a strategy that I'll call the card method. Think of each of these amenities as being a card, so that each house may have 3, 2, 1, or 0 cards. There are 90 air conditioning cards, 75 sun porch cards, and 45 swimming pool cards. That makes 210 cards in total. These 210 cards are distributed among the 150 houses. Let's start breaking this problem down. 5 of these houses have 3 amenities each, so that accounts for 15 cards. Then 5 houses don't have any amenities. This leaves 195 cards spread among the remaining 140 houses. We know that each of these 140 houses has at least one amenity, so let's visualize going around and giving each house a card. How many cards do we have left in our hand? That would be 195 minus 140 equals 55 cards. And what will we do with these remaining cards? We'll give some houses a second card. So, 55 houses get a second card, meaning that 55 houses have exactly 2 amenities, and that's the right answer. The key idea of this card method is that it helps us keep separate the concepts of members of the set, that's houses in this situation, and set membership, that would be amenities. By visualizing set membership as a card, we can flexibly navigate many different variants of three set problems. Check out the link below for a follow-up task.